Hi guys. Okay, let everybody join in. I think we've got what, 3 viewers right now. Let everybody join in. Yes. Hi Manish. Yep, we can see you now. Hi Archana. Okay, so we've got our usual audience pouring in. Achha, by the way, we are trying a new setup today, and having Amra by my side. Let's see.
Yeah.
Trying something new. Yeah, trying something new this time. Let's see. Whenever you guys join in, let's see. We'll give a few more minutes for people to join in, and then we'll see. By the way, let me know if you like audio, the visuals, everything is fine. Archana, Manish, can you guys see it properly? Yes, they can see properly, so that's good. Okay, let's wait for a few more folks to join in and then we'll start. Hi Gargi, welcome. Hi Shreyan. Hi Shreyan. Emma, let's wait for a few more minutes, then I'll hand it over to you after your introduction.
Okay. I'm fine with waiting.
I'm calling in the army so that we have sufficient viewers to start our session. Okay, by the way, how many of let's do a quick round of questions by the time people join in. So how many of you actually thought of moving to another city after government announced that you can move between different cities now? How many of you actually shifted from your place to another one? I did actually. So I'm asking I'm asking if anybody did the same. I think there is some delay, Amra. Already home. Shreyan is already home. Okay, good to hear that. I Thanks, Yash. We haven't started yet. I'm actually inviting a lot of speakers now from various parts of the world, and trying to bring the knowledge which possess when it comes to serverless to our community, so that we all can benefit, we all can learn, we all can grow, and help our community to get more traction when it comes to serverless. Ignore the background sounds and stuff for this stream, because I switched places, and apparently Amra is also not in his home, so yeah, there could be glitches on the way during the seminar. So pardon us for that for this time.
This is Ramadan Eve in Turkey. and my wife just wanted to stay with her family because there's also a lockdown now. Like if we couldn't get here yesterday, we won't be able to actually spend the Ramadan feast with my in-laws, and that's why last night I arrived here, and my internet connection was a lot better in my home. And here I'm actually a bit worried if I lost the connection, but I hope not. And I don't have my usual working environment. I'm in the now living rooms of them. I took everyone out and just actually talking with you.
Same, same thing with me. I spent us switching back the routers. So you have this default routers which comes from the ISPs, and then you have this home like more powerful routers, right, which can handle connections much better. So I was doing that since last couple of hours, managed to do it, touch the further screen, and I think the connection is gonna stable for the stream going onwards.
Hopefully.
Okay. Cool, no worries. So, Emra, why don't we start with your introduction so that people could, get a chance to know you better, and then I'll quickly hand it over to you so that you can start with your session. Okay, so guys, I'll give you a bit of history. How we actually got connected. So I've started working on serverless since the day I started my company. I was fascinated the way we could leverage the overall capabilities when it comes to serverless. And the main advantage that I'd seen at that time when I started my own company was, if I want to create a product, okay, how can I make it cost effective so that it helps me to go toe to toe with other players who are already established in the community, right? So, and that's where I've kind of explored the serverless and understood that if I build my product using serverless as a framework, it would help me to get the better performance with a lesser cost when it comes to resources running on a cloud infrastructure. And at the same time, I did had a bigger team, right, who could keep on maintaining the servers and all the deployments that you do on cloud, right? You basically need a good amount of team members to support that. But when it comes to serverless, once you deploy something, it becomes easier for you to manage, because you are not responsible for managing the backend infrastructure. Everything is being maintained by the public cloud provider. Whatever you're using, either you're using Google, either you're using Azure, whatever you're using, they take away all your pain in managing the infrastructure, right? The only thing that you need to do is to give them a code which you want to execute. So that's how I started my journey with serverless. And on the way, I've encountered the limitations which are there when you work with any framework, right? There are pros and cons. So with serverless, one of the main challenge that I'd seen is, how do I monitor the infrastructure? Okay, in usual practice, whenever you create a stack, whether you use LAMP, Java, whatever .NET, whatever technology that you're using, you're deploying that onto a server, and then you basically monitor the server resources like memory, CPU, what is the response time, and all that stuff. That's the usual monitoring that you do, correct? But when you deploy something with serverless, you don't the things that you need to monitor when you deploy your stack with serverless is completely changed. You are looking at how much time it's taking for a Lambda function to run, how much memory was consumed when my Lambda function ran. So the dynamics of monitoring a stack when you deploy it in serverless versus when you deploy it in any other framework, it's completely changed. Okay, and that's when I started exploring what are the different options are available in the market, and that's how I stumbled upon. Actually, I'll use this word stumbled upon because we didn't had any connection. Me, Emra, Ismail, like we were never connected. I went to their website. I've seen what they have, and then I reached out to them. I believe you and Ismail, we three were the first. We had the first meeting, and then I started utilizing the product. Right?
Exactly. Yeah, I remember that. And
It's been a year and a half, I believe.
yeah, like Ismail normally like takes these meetings, but like he said me that like there's now a professional. He just wanted to understand the infrastructure. Could you please also come and explain like some about the roadmap, because he's the customer success, I'm the product person, and I attended that meeting, and it all started a good friendship.
Yeah, and rest is history, I believe. I think we have used Tundra for our for our serverless monitoring for one of our products. Not just that, we actually recommended this product to a couple of our customers as well, who's been using Tundra for quite some time now. So the idea behind this session today was to bring all that learnings that I had by having interaction with Tundra team, right? Specifically with Emra. Like I've been like they have this Slack community. You can just go and connect to them on Slack, and right away whenever you are stuck, you just ask them, and everybody jumps in to answer the questions. That's something which I found it very convenient, because see in this 21st century, what happens is time is everything, right? And when I have somebody, whenever I am stuck, if I can go and approach them and get things moving, nothing like it, right? So Emra, by the way, leads, like he heads the product with Tundra. He's the VP of product at Tundra.io. Okay, it's a serverless monitoring tool. So how, like, the discussion that we are going to have today is, from the day you are starting to develop the serverless stacks, from there to when you push something into production, how what kind of a role and observability takes place when you have something in dev, when you have something in production. What are the different things that you need to take care, what are the different things that you should do it from development when you move things to production, what are the different parameters that you should look at. So that's something that Emra is going to help us to understand. And with that, Emra, I'll hand it over to you. Session is all yours. I'm gonna hang out on chat and talk to all the lovely people who's gonna join our stream. Okay, over to you, Emra.
Okay, thanks a lot, Ankit, and thanks a lot for hosting me today, and thanks a lot everyone who's joining today to us. For those who just joined, I should also say that today is the Ramadan Feast Eve, and I'm in my in-laws, and my internet connection here is not as good as at my home, but we will see. It seems like we won't have that much of problem. And today I'm going to talk to you about the serverless observability, how we can take advantage of it from development to production. So let's first start with what makes observability special. So when I talk about observability to people, the first question they ask to me is, I think you are just trying to invent a buzzword, kind of a new word for monitoring. This is nothing different than monitoring, but you are just calling it observability to make it like more cooler. And I know companies who do this, but it is actually not in this way. So because observability is much more broader than the what monitoring it is. So this is the images from this perfect article by Sindhi, and this article actually says that we do testing for the things that we know, and we just wanted to verify something. And we do monitoring because we predict that there might be some failures that we can imagine. And when we do testing and monitoring all together, we actually actually in a quite a good shape of managing our system. But when it comes to distributed systems, there might be many, I mean, like really many failures that can happen. So in order to be ready for that, you need to have more than testing and monitoring. So because you don't know everything, you don't know what type of failures your distributed systems can face, and that's why the the notion of observability actually steps in. I will explain a bit more now, and I think maybe some of you missed the exam. So this is like the observability or like the failure matrix, and like in a serverless or in any software systems, there are issues which are known, and there are issues which you know how to actually react. So these are known knowns. So you know that this thing can happen, and you know that like how you are going to react when these things happen. And in software systems, there are also known unknowns. So things that you know that can happen, but those things that you don't know how to react because there might be some other reasons. So like when you look at this matrix, monitoring is only useful for known knowns and maybe for known unknowns. But the thing is that you don't know the failures that you can face in an distributed system. So for the rest of the matrix, you will need observability. And when we actually compare them, observability and monitoring together, one actually very important difference is monitoring is an activity while observability is a state. So this actually sums up everything. So in monitoring, you or ops people in your company does monitoring to understand the system, to follow up some metrics, to like make the things smoother. But observability is not a actually activity. It's a state of your system. You make something, you use a tool like ours, or you build your own, but at the end of the day, what you are aiming is to make your system debuggable when you face an issue. And monitoring actually gives you answers, so you can check a chart and see that, hey, there's a peak here, and it must be because of this, so you know what happens there. But observability lets you ask questions when you face the problem. Hey, there's this down, so let me ask that, like, how, what's the impact of that? What is the, what's the downstream service quality? So you can ask such questions in distributed systems, but you can't ask these questions by just checking charts. In monitoring, like you mainly check the infrastructure level metrics and logs, such as you check the CPU usage, you check the garbage collector, and the things that you should also care about. But in observability, you are more motivated on application level metrics like distributed tracing, logs, and the other metrics. Another very important difference is that monitoring is mostly, like most of the time, is an ops discipline. Like it's conducted by operations people, but observability is actually owned by both developers and also ops people. So observability is a thing for DevOps, in my opinion. And so you might say that like we have CloudWatch logs, we have again CloudWatch metrics, and we have X-ray. So is it possible in serverless? It is and it is not actually. So there's not only one thinking of this, because these services are all separated. So there is CloudWatch logs, but you cannot relate them with X-ray. There's CloudWatch metrics, but you cannot relate them with the logs. So there's no connection in between, and there are some limitations or the limitations of these services. First of all, CloudWatch, let's say, is ugly, and X-ray cannot actually trace everything, and metrics are the out of box metrics. And let's now talk about like what are the observability challenges in serverless? So let's say that you are not happy with the what. But by the way, I'm mostly talking about AWS perspective because I'm mostly knowledgeable about this. But this actually applies to the other cloud vendors like Azure or GCP. But to be honest, I'm not that knowledgeable to dive into detail in them. But I'm better in AWS. That's why I'm giving that example. But the things that I will list now is not actually specific to AWS. So, like since you actually gave the access to the cloud vendors, since you don't care now about the how the underlying infrastructure works, you're actually also losing something. You have no access to underlying infrastructure. That's why you cannot install an agent. You cannot actually set up write a script yourself to understand what's happening in your serverless architecture. So you should take whatever cloud vendor gives you, or you can just implement a monitoring system yourself, and you will accept that this will create an overhead to you. I will explain in a minute. And this overhead might be about like you will write a code that will run along with your code to gather some intelligence, and I trust you that you will not write a very bad code that will actually create that much of overhead. This is not the problematic part. The problematic part is actually transporting the data you generate to the backend, and to visualize the data, and to have more insights about it. Since there is no other time in serverless, you should use the invocation time, and you should make an HTTP connection to your backend to take the data out. And this will add, according to our benchmarks, more than 100 milliseconds if you build it yourself. So, you will make an HTTP connection, and this will cause an overhead in your application, and this actually attacks the first idea of serverless at the first place. And since everything is event driven and distributed, so let's say you have you have implemented your own systems, you plugged it into every function, but like looking at the functions one by one is not enough, because this one function actually triggers another function asynchronously by just sending an event, and you cannot. It is the linking all of the invocations together is also another problem. So, like, I actually showed you the problem, and before jumping into the solutions and like talking about best practices, let me introduce myself a bit longer than before. So, my name is Emrah Shamdan, and I'm living in Ankara, Turkey. And I was a developer before I transitioned to product manager job for more than 6 years. I'm now product manager for more than 2 years, and I've been with Tundra team since like almost the beginning of my product management career. And I'm a serverless enthusiast by heart. Last year we organized Serverless TS Istanbul, and that was an on-site event. It was very fun. I'm the co-organizer of Serverless Turkey meetup, and I'm also co-organizer of Serverless TS Virtual, which will be actually coming to APAC region in July. We are doing quarterly virtual conferences all around the world. The first was in April, and the second one will be in July, and the third one will be in October. And we will continue to organize Serverless TS Virtual even after the pandemic ends, because we saw in the first event that actually having a really top quality of serverless days online makes everyone learning this top quality content. So even if the on-site events are back, we will continue to make serverless TS Virtual organized every quarter. And you can reach out me over Twitter with my tag, and you can reach out me by email anytime you want to ask something. And as Ankit says, we have a Slack community channel. We have a Slack community, and this is open to everyone. I can invite anyone who wants. And we are always talking about serverless, and mostly it's about like observability and also Tundra features. But this is might be like the fastest way of reaching out to me. And let's talk about today's agenda then. So I will first again try to convince you that serverless observability is crucial. So you can't just trust what you already have and start building a system for production in serverless. And I will revisit the 3 pillars of observability discussion. And I will go over the observability best practices at serverless. And we have this hierarchy of observability needs, which is being inspired by Maslow's hierarchy of like life needs. This is kind of a good analogy that I like to make, and I will go over this one. So let's actually step back and look at this. So how we came to this point of serverless. So in 90s we did have these physical servers, which we are actually managing it physically. You were responsible of the temperature of the room. You were responsible of the servers itself and everything else. And like in 2000s, VMs came, and you were putting like more than one service to your physical service, and you have VMs. And in 1910s, maybe even earlier, cloud computing became a phenomenon, and you will be able to host your service on cloud. And now we have serverless. In cloud computing, you actually stop thinking about servers physically, but they are still in some data center, and you were actually still managing them on cloud. And this ended by serverless. So because when serverless is here, you just, as Ankit says, give your code to the cloud vendor, and they are just running it in a server, of course, in a container that you don't care about. It scales automatically. It is secure by definition. It is reliable by definition. But this is the picture that makes me really sad and happy at the same time, because I love Pokemons, and also sad because serverless architectures can be very complex. So when you first start with serverless, you have this function gets triggered by API gateway, and writes the results to Dynamo or Postgre like this. After a while, you will notice that you are now architecting more event-driven architectures. This Lambda function writes something to SNS, it notifies to other functions asynchronously. This function does something, writes the result to SQS, the another function pulls from SQS, and so on. So you have an event-driven architecture, which I can call Charmeleon. And after a while, you have several different event-driven architectures talking to each other, again with events. So it makes it a bit more complicated than usual. So it becomes a Charizard. So let's think that like when you have a problem in your Charizard, how are you going to understand it first? How are you going to measure that? What was the impact of it to other downstream services? What was the impact of it to your customers? And how you are going to fix it easily. So that's why observability is crucial. That's why checking at cloud virtual metrics and looking at logs cannot actually help you to understand such a distributed and complex architecture. And when I'm talking about distributed and complex, I'm not saying that these architectures are bad, because these architectures, just as Ankit says, gets rid of your like many concerns and make your systems more robust, because now you have atomic jobs done by several functions. Even if it fails, it shouldn't be failing that badly. So let's talk about the observability pillars very briefly. So as you may know, observability is based on 3 pillars. So the first one and the most important one is the traces. It just gives you an idea about the life cycle of an transaction in distributed systems. So service A started at T0, and it does its job and writes something to SQS queue at T5. This SQS queue asynchronously triggers another service B at, let's say, T15, and traces gives you all the life cycle of this span. And on the other hand, there is metrics. Like, as we remember, you can see the memory usage, you can see the invocation duration, you can see the I don't know, concurrent executions. You can see the number of throttles, hopefully not. And this gives you an idea. And the logs, logs are the most primitive but the most, trusted resources of understanding a system I can accept. But its logs only cannot help you understand. So your logs, this thing happened at this time. This is a log view, and you can actually build a good product or tool and company even into your application when you have all the three pillars of this. So when you have all this, you can build a visualization on top of that. This is another concern. You can run machine learning algorithms, and you can generate insights, and you can do alerting on top of that. But if you are missing any of these traces, all the other thing that you are doing is actually missing an important point. And let's talk about the observability best practices one by one for these pillars. So let's talk about logging first. So as I say, this is the most primitive but the most trusted resources. But please don't just write logs of like system out. So try to write logs with a structured way with JSONs, and this will make a lot easier to actually interpret the logs when you have a problem. Because when you have a structured log mechanism, mostly on JSON, you can index some of the key values, and you can search for them very fastly on any platform, like let's say Kibana or Splunk or whatever you are using, Logz.io or Tundra, whatever. And try to be automating logging when possible. So if you are using a library, let's say for going for some transactions, if this library has an automated logging, enable it. At least, not maybe you may not prefer to do this on production, and you are right, because CloudWatch is not that cheap. But you can enable it on staging and just try to understand what's going on there, and have a switch somewhere around to actually enable and disable such type of loading without actually deploying the application. This is actually pointing this part. You need to have a centralized ingestion and indexing mechanism. So you have to have this switch which makes the log ingestion heavy or low, and you also have a good indexing mechanism in the place that you are actually keeping the logs. You should have a good indexing mechanism there. And as I say, CloudWatch is not cheap, and if you keep your logs forever there, it will continue costing something to you, and this something can be really bigger than you would expect. And that's why you should retire your logs after, let's say, 2 days, after 1 week, whatever you need it. And this is because of that. Like storing of logs is 3 cents per gigabyte, and think of the cost that you can actually have. So let's go about like metrics. In serverless, the definition of critical metric has changed. So like maybe when you are running a container application, you will be able to look at the CPU usage. You will be able to see the number of garbage collectors working. You will be able to see the disk I/O, but these are not really important. But there are some important metrics still. Memory usage, because most of the time you are allocating a memory for your serverless function. And if, let's say, your allocated memory is 1 gigabyte, and if the memory usage goes very close to it, this is not a good signal. So you can actually look at this and try to either look your application to maybe fine tune it to consume less memory, or increase your memory allocation just to make it more safe. And timeouts, you should see that like how many times the timeouts are happening. You should see the average or 99 percentile durations to prevent timeouts. And you should also have an eye on concrete executions, because maybe you can have it's very unlikely unless you are under a really big traffic, but you may have set a concrete execution limit to your Lambda function, and you may be reaching out this concrete execution limit faster than you can expect. And there are also application level metrics, which might be number of 404 errors, number of 5xx errors, and these becomes really important because we are talking over HTTP, and this you can check out this. Again, you may want to look at the durations. Average duration can show you what's happening, but you should definitely check the maximum or P99 durations. And in this case, like in any application, you should also have the business context metrics, the metrics that you own. And this is, how frequent an event occurs, what's the value of a specific variable in your application. Let's say you are using an IoT application with serverless, and you got the temperature of a sensor, and this temperature can be very important for your business, and you should keep an eye on that. And you should be able to aggregate all these type of metrics into a single pane of glass. And this single pane of glass should also be, embedded into traces and logs. And let's talk about tracing. As I say, we are accustomed to logs and metrics from other systems as well, but tracing becomes much more important with distributed architectures, with containers and serverless. And in serverless, it becomes even more important. Because serverless is event-driven and asynchronous. So as I just give the example in minutes, there are like tens of services included in a transaction. So how can you keep track of, hey, this is my transaction was here, then it jumps to somewhere else, and now it's here. This is actually very hard to keep track of these just by looking at logs. You may find yourself drawing a transaction tracing by using logs, and this is actually very painful. And you should also not only doing this for AWS services, but also for third-party APIs. Let's say you just go to Twilio to send an SMS. You should be able to understand how long does it taking, because if you do it synchronously, this will block your function being finished, and it will cost you money. You should be able to use tracing as a glue to correlate logs and metrics together. So all the logs and metrics will be actually carried by traces. In this way, you can see all together. You can see them all together in the body of traces. And when we talk about traces, of course, we are talking about distributed tracing, which lets you understand asynchronous systems. But there are two issues: how you can produce these traces, and how, let's say that you produce those, how can you visualize that? So how can you visualize those traces so that you can make decisions, you can fix the issues, you can pinpoint the problematic parts, and you can debug the applications and make your customers happy at the end of the day. So let's start talking with how to generate traces part. X-Ray still have some problems. So it's now supporting finally SQS and SNS, but when there is an stream-based application like Dynamo or Kinesis, X-Ray is not still supporting the traces propagating from these. And when you have non-AWS services, let's say Redis Cache, X-Ray is not supporting that too as well. And the sad cure about this is instrumenting every service yourself. And what you should do here is that you should inject relevant data to the spans, and you should make them more meaningful. Maybe I should also talk about what the span is. Span is the one entity which represents a time interval. It started in, let's say, T0 and ended in T5, and it has this data in it. So let's say you are reaching out a database, and you are just saying that I reached out to this database with this name, with this IP address, with this identifiers, PostgreSQL version, whatever you call, these are all the data in this span, and I just went to this database at T0. I made this query. Response was that thing, and I came up. This interaction ended at T5. Think about how powerful it can be. And you should put the request and response payload. You should have the HTTP status code there. And this is only one span. So now you should also correlate the spans all together to have the distributed traces. So you should inject correlation IDs. So, hey, this is the transaction number 1. I went to this database responded me, and then I write something to SQS, and this is still transaction number 1. And this SQS triggers another Lambda function. You should still put this transaction number 1 to this trace as well. So, you should propagate these correlation IDs between services, and so that you can visualize them later. Luckily, there are some open source frameworks for that. There is open tracing and open census, but they are now merging their forces to generate open telemetry. And open telemetry will be an open source framework which will set standards, which will set SDKs to write codes for instrumenting an application. Then there is something called observability-driven development, which is just quite a new to the software development. So, like in test-driven development, you do observability while you are doing development. So this is kind of an interesting discussion. In order to understand an unknown unknowns, observability-driven development says that, like you are writing tests for the issues that you know, you should write logs, you should create traces, you should put some metrics in it while you are developing the application. And this is like using the open source libraries. You can actually do it yourself. And I can say there are some fanatics of this approach, and they say that automatical tools like Tundra cannot know your system better than you, and it is true. So I'm not actually disagreeing this, but they say that instrument everything yourself, and in order to do so, you should put logs about I was there, I was in that part of the application, I was doing that part of the code. Hey, this is my log print, and you should write this. And this is not a replacement for test-driven, because you are doing test-driven, like unit tests and integration tests for the things that you already know. Here, what the application teams are trying to achieve is that generating huge amounts of logs, so that when there's a problem, they can actually understand it. And you should think of the answers that you will be looking for. This is kind of my approach to this problem. If you are thinking about questions, why don't you just ask your tool to implement this question in the applications, and you can get the answer instantly without you worrying about this. So all these software as a service and serverless things actually imposes us to outsource some stuff. And I'm saying that if you can still outsource it to a tool like Tundra or whatever you call it. And structured logging and the manual instrumentation is very important. But there are some problems with that, and these are the serious problems. So how can you make sure that you printed enough number of or enough level of logs that you are covering all the observability needs? And how can you actually get used to writing codes for observability, and how can you be sure that it's going well? And this is and in this way you can actually not sample a thing, and because when there's a problem, you should have all data at hand to understand it. So what we are proposing instead is automated instrumentation is necessary. So you should use a tool which do automated instrumentation, But this tool should also let you do manual instrumentation. So use observability as service like Tundra and put your focus on the value that you can deliver to your customers. Use tagging to embed the business context into the traces. This tagging can be any user identifier, so you can say that I'd like to see the traces in which I'm processing the data of my user with ID, let's say 5. And you can see that I'd like to see the traces in which that I'm processing deleting a user event. And I'd like to see the traces in which the money that I'm charging from my customer is more than $50. Your custom KPIs. And that's why you should just keep the level of manual thing is burden, because it pollutes your code. It's actually hard to test because you are now writing another code snippet, and you should also test it and see it is still worthwhile to have this part of code. This is kind of a hard way of onboarding a new engineer to your team. So let's bring on to our topic, to how to visualize the traces. It becomes like you should have time-sensitive flow diagrams, because just metric charts are not enough. And there are open source solutions, but they might require modification of your different data, and it's another thing to maintain. So you write your instrumentation yourself using OpenTelemetry, and luckily we have I'm coming to this Jaeger and Zipkin to visualize this. You don't need to modify your data in this case. But how can you add custom capabilities to Jaeger to, let's say, set up an alert on top of a trace? So they are just visualizing. They are not doing anything else. So in my opinion, so this is kind of our approach to observability as Tundra. You don't need to try it yourself, because what was like, remember the first value of serverless. It just makes you get rid of the servers, the infrastructure concerns, scalability and reliability and everything else, and it lets you to focus on the value that you can deliver to your customers. So why don't you build the observability for it yourself, and you are losing the focus. And you don't need to think about, like, let's say I'm using this library for reading from my database, and I just want to change the library that I'm using. So you will start thinking about, okay, I need to instrument this library as well. So it is kind of a not very maintainable stuff. And you should take advantage of automated setup, zero maintenance solutions, and you should actually stop doing manual instrumentation or manual visualization. And this is the only place that I will talk about. Maybe there are other places, but you should have tools like Tundra, which have automated alerts and ability to pinpoint a problem, automated indexes on high cardinality data that it produces. And I'm not saying that don't use manual instrumentation. I'm saying that use an automated tool that lets you do manual instrumentation. So this is another problem. So in our competition, I say there are tools who are evangelizing for manual instrumentation, and there are, because they say that only you can know your application better, the best. Yeah, this is true. And there are tools that, hey, it is so hard to do manual instrumentation, just use automated, you don't need manual instrumentation. So we are closer to that camp, because we also say that we have automated instrumentation, but we also say that we are letting you do manual instrumentation if you really need it. So in this way, you can actually use it together. So this is our hierarchy of observability needs. You have whole system. Remember the Charizard, and in this system there are some business flows. Let's say deleting a user, or let's say processing a payment, and these are the business flows happening in your system, and you should be following them with unique traces. And let's say processing a payment is a business flow, but this business flow is being triggered by, let's say, hundreds of times in hours. So each and every one of those is called transactions, in which there are multiple functions, there are third-party APIs, but it all makes up a transaction together. And you can understand these transactions using distributed tracing. And as I say, in these transactions, there are different functions. So one function gets the request, how much the payment is. The other function notifies the other services, let's say the invoice service to generate the invoice, and also inventory service to manage the inventory. And you have the one processed payment transaction. But there are different functions in it, as I say, and you should be checking the invocations of these functions to what's happening here. In these functions, there are some code blocks which might be quite critical for your use case, and these code blocks, when you need to understand these code blocks, you should be able to do debugging in your architecture. So let's go over them one by one. Let's talk about the whole system and architecture overview. So you can't have the bigger screen to look at the charts of let's count together 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 functions. We have 12 functions, and I didn't even count the resources here. And there are some resources which are not on AWS, like Redis. There are some third-party APIs. It is very hard to understand such kind of a system by just looking at metric charts. Instead, you should have an architectural overview that will let you understand an issue at a glance. So let's look at this. So you see that there's a problem with Redis. All the edges going into Redis is red. So which means that Redis is returning errors, and it already affects 3 functions. So in this way, by just looking at this architectural diagram live, you see what is wrong with your system. This is the way of understanding or let's say spotting an issue. You didn't understand anything now yet, but you spot that there's a problem with Redis. And the other stuff important is the business flows. You should this is a processing a payment example. This happens thousands of times in a day, and processing a payment is the roof for these transactions. So deleting a team here. So it includes these resources. It happened like this many of time. It is the average time it takes, and having the flows, understanding all the flows in your architecture is very important, because it just keeps you lets you keep an inventory of what services do you have. So you have deleting a team service, you have, let's say, adding a team service, and in this way, when a new engineer is joining the team, you can just show them this page that, hey, this is the services that we have, and these are the metrics about this, and you can just keep track of the high-level KPIs of that type of application. So let's say that you have the target of having 100 users onboarded in your system. You can look at your observability tool and see if you are keeping up with this target as well. And there is also an interesting side effect of having all list of the flows in your systems. Sometimes you may be using, and please, hopefully you are not, using a third-party library that is taking your data out. So because if you don't configure the security groups, if you don't give the correct IAM permissions, such things can happen, and such things can happen very usually. So when you notice a different flow that shouldn't be happening there, you can actually catch a security breach there. This is a very important side effect. And I can now come to serverless transactions. So like one instance of an business flow. This is one instance of a business flow, and you are just tracing the distributed transactions. A chain of one invocation, second invocation, and third invocation. This is all a picture of that, and you can understand what is wrong here. You can see it is red and it is erroneous, and you can see this is there's a latency here. And you can see what is the technical and business impact. So there's a problem here, but you see that it is not red, and it seems that Redis got an error, but neither Lambda function got this error, nor your customer. This is a good news. And now it's time to look at the invocations. So we are now looking at an invocation on Tundra. You see that like this application took 300 milliseconds, and you see how much time it actually spent in resources. You can see how much time the methods in the application cost. You can see how much time the interactions between resources cost, and you can see the metrics like the memory usage, CPU usage, such thing. And these all happens with the automated tracing. And you should also be doing debugging in your application. And I mean debugging like in old days, not with the logs. So in serverless generally, debugging works as you see a problem, you are digging the logs to understand what was the problem. If you are lucky enough, you understand the problem, you implement the solution, and just to verify it, you put a new log statement in place, you deploy that solution, you see the result. If you are lucky enough, if it is the problem is as you expect, you are good. But if you are not, you will see another problem and you will need to write another log statement. And we are calling this thing is doom of serverless debugging because it takes so many time. And Tundra has the post-execution debugging. So when you look at the methods in your application, which happens like in the history, you see how the local variables values are changing in this view. You can step in the application and you can step through and see the changes happening in your application. You can't change anything, but you can understand very deeply what happened inside. And Tundra also have a real-time debugging feature, which is actually setting a bridge between your real-time cloud environment, AWS environment, and on your and your ID. So, like in this example, you run the application here, and it hits the breakpoint you put on your ID. This is something like magical that we invented, and everyone likes this solution a lot. So you are debugging an application from your ID real time while it's running on cloud, and this gives you a lot of flexibility of understanding the system. So I'm coming to end of my talk now. Let's talk about the key takeaways. So serverless observability is not an after production issue. You cannot say that, hey, let's go into production as fast as possible. We can think about observability later. So there is something called observability driven development. There are like many tools which tells you that, hey, you should think about observability at the first day. And you should be actually very serious about that, because if you discover that you need an observability tool for your system after you go into production, that might be a bit late for you, because you may be already facing really serious problems. And you should have all the three pillars, traces, metrics, and logs all together, just to make it more effective. Automation is needed, but if you need it, you should also write some instrumentation code with observability-driven development. And you should not look at the functions one by one. You should look at all your architecture, and you should look beyond the functions, and you should look at the architecture in a more holistic way to discover the bottlenecks with an architectural view. And as I said, this is the serverless transaction, a chain of invocations between resources, Lambda functions, and APIs. You should have the full tracing. And debugging is very important when you need to spot bad coding practices. Thanks a lot for listening to me today. It was the end of my question, and since I am using only my laptop, I couldn't see any question. If you have any questions now, we can talk about them.
Hey, Matt, thanks a lot. I am back online. Okay, so we've got 2-3 questions, but I believe it's more in general for serverless rather than things related to monitoring. Let's take that up. And then I have a question which I want you to answer. So first question that I got was from Sandeep. So Sandeep works as a solution specialist in Windows platform, and he's learning AWS. He wants to understand, what could be a path for him to move from, his current stack into serverless.
So like everyone has a different story. It doesn't need to be same for everyone, but you might be like looking at improving a process in your company. So you can say that, hey, there are some DevOps processes which are using cron type tasks. So you can just turn it into serverless, and it will cost a lot less money, and it will be a lot easier to implement. You should just have the CloudWatch events, trigger a function, and let's say that it actually clears all the garbage collectors in your EC2 machines. So you can use serverless to fix server full applications as a starting point. And I know some friends which just build a serverless API for a really for a small business, and it just uses an API gateway and Lambda function, and let's say a DynamoDB table, and it is just all. Remember the Charmander there, and it can be an option. And in these days, I'm also talking about AWS Lambda might not be the only way of starting serverless. So because there are now some vendors like Netlify, like Versal, which do serverless sites rendering, and you still do serverless functions there, and it is a lot more controlled environment. It's very hard to make mistake there, because the serverless functions there is just getting requests and returning a response, and it resembles the servers in a better way. But you start doing serverless. This might be an inspiring start also.
Correct. I mean, just to give an example, right? I've been working with Cloudflare guys. They also have Cloudflare workers, which again, is serverless functions that you can run on top of your website. The good point about that is, for example, Netlify also does the same thing. So, everything is available on edge. So when you have something which you basically need a sub-second delivery, right? This kind of functions, utilizing the edge compute would help us a lot. And on the other side, there are services which are very event-driven. For an example, you see a translation service, right? If you're running a website and you're looking for something in which you need to have a translation done for certain, non-English speakers, and you want to have something, you don't need to create a whole service for that, right? You can simply make API calls directly from those edge compute resources and get the translation done. So that's the use cases are different for different people. So Sandeep, if you are starting up new with serverless, best way as Emra mentioned, cron jobs. So in whatever stack that we design, we always have something which runs on a regular basis. You have some administrative stuff within your stack, which you usually do it within the application. It takes up a lot of resources at times. But when you move that to serverless, you don't have to worry about it. And see, serverless like AWS Lambda also supports a .NET library in by default. So you don't have to learn a new language and then move from here to serverless. Again, Emma, another question that I have is somewhat similar to this, but one thing that he mentioned, it's a question from Yash, that so how to, what's a good serverless learning path for a non-programmer, and he wants to move from novice to a serverless hero.
So this will be a long way, but I think it has a very good view, and I would also take this road. So I can say that if you know about Emily Shea, AWS Business Development Manager. So she's a business development manager in serverless, but she is graduated from Chinese language. So she has no programming experience. She has no academic, computer science background. But now she is working as a business development manager in serverless, she just wanted to start with serverless, and I'm actually admiring her story. So I just found she just bring up the resources that the pet that she was working for uh, while learning serverless. It is quite inspiring and can actually teach a lot to anyone about how can a non-programming person get started with serverless. And now she has a Chinese vocabulary website that actually translates Chinese to English using serverless. So it just gives up all the way around to how can you do this. I just send it on private chat to Ankit. I think you can share it with the attendees later,
Sure,
right?
sure, no problem, no problem. And so yeah, that's the fun part. For an example, if this would be very different thing to share on this platform, but I'm also a non-coder. I've never done coding. Like I used to be good at doing shell scripting earlier, and then when I started having this my own company and want to create my own product, when I started learning serverless, the for example, I've started working with AWS, so I'll talk about that, and then I do have certification in Google as well. I've gone through their Google Cloud Run and everything as well. So I'm not comparing the cloud providers here, but when I started my journey, with AWS, I find it very easy and accustomed to their documentation style. Like I'm not somebody who would go to YouTube and search different videos and then dig up the content and then start configuring stuff. I'm a person who would like to go to the default documentation given by the product itself and then go through that. And it was so easy in terms of gauging those steps by steps material. And at the end of the day, if you know the logic behind what business function that you want to execute, you could simply understand the task. Like you could simply understand the structure that is required to run a Lambda function. That is
Yeah,
the beauty of using serverless functions, because
exactly.
you don't have to invest time and money to understand the dynamics of running the system. Okay. And in my 12 years of career, I've met so many different developers, and to understand that usually they don't be on the side where they see their application running, how it's being deployed, how it's being in production, how it's been running. That's the exposure that developers usually don't get. But nowadays, for example, with serverless, whatever you're writing, it itself goes into production, and it runs the way you push, right? So
Yeah.
that's the beauty of it, right? As a developer, I can push my code directly to the production without without worrying about anything else. I admire Netflix that way, right? Netflix has what, thousands of deployment in a day without worrying about infrastructure, right? That this velocity at which they provide features is phenomenal, right? So you know adopting to serverless means that you have to understand do's and don'ts of how to push your code, and once you know that, it would become easier for you to start churning out functionalities at a very good speed. One of the good feature of using serverless framework is this, that your response to like your any feature, your time to market becomes very less, because you're only and only focusing on what functionality that you have to deliver. You don't have to think of how many traffic that I'll get, what is the capacity that I have to build, what is the when I used to work with Java based application, we used to think of heap memory and how to, like, whether I'm doing heap cleanup and all that stuff. But with the serverless, you don't have to worry about that, because everything is instantaneous. So you run your application, you run your code. Once it has been executed, that code gets resolved, and the new transaction starts up a new container, and starts up a new thread for them to run. So the conventional problem that you see in a normal stack will not occur to you when you move to serverless. Of course, there are other challenges that you have to solve, and that's the plan that I have for this community. So I'm bringing different people in, talking about various aspects on serverless. So when you move to serverless, it's easy. Like you start coding a Lambda function, you'll be able to walk around it. But what after that? How do you monitor those functions? How do you take the costing part? The costing is very small, but over the time when you have a production grade machine pumping up all the requests, it's gonna be very difficult, and
Yeah.
that's when you will have to adjust the cost and all that stuff. So yeah, I we have two more questions, Emra. I hope we have some time.
I have to.
uh, okay, so next question is from Jigar. So Jigar is mentioning what is the best practice in terms of development to go serverless with AWS.
So, I mean, as a developer, actually, the best practice is like the don't forget to retire the logs. As I say, a CloudWatch can be a lot more costly than AWS Lambda, and the use the in my opinion, like as a I'm not developing most of the time, but when I'm developing, I'm taking advantage of VS Code plugin of AWS a lot, and also VS Code plugin of Tundra, just to make it more easier. And but if you ask about as an organization, you can think about like having a different environment for every developer, just to make them more comfortable. And you can easily do this using AWS organizations when an AWS service, and that makes it even easier. And yeah, this question is a bit so broad that I cannot actually list one thing. That's why I'm just trying to say the things that's coming to my mind. If you can make it more specific, I can answer as well.
Sure. So I'll just add a bit of information to this. So Jigar, when we're talking about best practices around implementing a serverless stack in AWS, it all depends on what kind of components that you're using. For example, if you're using API gateway with Lambda and a CloudWatch to, it's the default stack that you are using to get certain business function done, I'll recommend you to, start doing it, understand different metrics which are there around this. So, for example, when you're running a Lambda function, how much time it's taking, what is the, memory usage that is being taken. And once you have a practical knowledge about it, okay, then, when you move that to production, run certain workloads, it would help you to gauge the production aspect, or a running a production knowledge of how to fine tune this application further. So that's something that I've been doing. There is no right and wrong when you work with serverless.
Exactly.
The same, like I can implement the same thing in 4 different ways when it comes to running something in serverless. You could use n number of tools, like you could use DynamoDB, you could use Aurora serverless as well. It's completely on you. You cannot have 100% serverless stack as well. So for example, on front end you use API gateway and Lambda, and on the back end you use your conventional RDS like MySQL or Postgres. It's completely fine. You don't have to transfer 100% into serverless from day one. But the idea is, you try to leverage serverless as and when you can, and try to offload your operational responsibility of running an infrastructure. That's the core, that's the gist of running the serverless infrastructure. You basically want to augment yourself from all the worries of managing and maintaining different cloud infrastructure.
And they say that it's a journey, not a destination.
Yes, it's a journey. It's not a destination. Yeah. Okay. One last question from Suresh. He's actually part of my team. So he's saying, implementing an async process in serverless is good choice or not? I think
it is. It is the best choice that you can do. So I can give an example from Tundra itself. So because like we, as Tundra is also running on serverless, and I was talking about like sending data back to Tundra backend. So like there are Tundra libraries running along with your code, and Tundra backend should take this data as fast as possible, so that your function won't experience any overhead, so minimal overhead. So everything is asynchronous there. So you get the data, and you should just say okay to the function, because you don't want to spend any more time about indexing data or just like generating insights, making it visible on the application. What you would do instead, you will say get the data and say okay, and the function will finish its job, and you will then take it, put it on a Kinesis stream, and it will trigger asynchronously a function which will actually process the data, make it ready for let's say indexing, and indexing in non-elastic search. Believe me, this process takes seconds, not even milliseconds, but we don't care about it because the function is already good, and data is being processed, and it will be visible to the customer in seconds, and it's no problem because the customer can run the function. Even if it fails, it won't take just milliseconds for him to take a look at Tundra console. It will take seconds, and it's being ready in seconds. And you first you are running your application as in the way that like your customer expects. Second, you are adding just a minimal overhead so that you are not causing any slowdowns in the applications. So if we try to make it in synchronous way, remember, like, we will add these seconds as an overhead to the function, and at the same time, it will be even like it will take even more time to for the data to become visible. So that was like asynchronous is everything. Event-driven asynchronous architecture is inevitable in serverless.
Correct. I mean, you take any transactions, in a normal plain world. For example, I'll continue the same example. When a subscriber signs up on your website, you would have to invoke a different channel for notifications and user creations and profiles and whatnot, right? In a normal world, what we do is we have a serialized code that gets executed one by one. But in this case, what happens is I can use the power of parallel processing. At the same time, I can give much better user experience to my end customers because everything becomes parallel. I can send out email notifications, thanks for signing up, and these are your next steps, and blah blah blah. All those stuff can easily be made available by this, async process. Payment processing, you have a lot of information coming back, and you need to process a lot of stuff in that could be a good way if you use async processing. Another feature that I usually like to use is the data aggregation. So for example, you are doing certain transactions, you are getting some information by different kind of searches and different things that people are doing on your website, and you want to aggregate some analytics on the back. So for a simple thought process, so you're running a travel-based website and you want to recommend certain destinations based on people's searches, right? I can run that service completely in parallel in the backend based on the inputs that users are giving right away, correct? Usually what happens is you have multiple services running to maintain that server, but when you have this, when you deploy this in serverless, what happens is essentially your whole application becomes parallel. So the difference from when I clicked on certain stuff and when I see a stuff being changed in recommendation, it is very less. That's the power of using async processing with serverless. So anything like event driven and async processing these are the two criteria for you as a developer to start using serverless frameworks. Anyway, so Emre, thanks a lot for joining in. And I know it's Ramadan Eve and you are there with your family, but you still took out some time for us. So happy Ramadan to you and to your family. And I would like to thank on behalf of the whole community. Thanks a lot for taking the time out. And yeah, we'll catch up again soon. Or doing more sessions like this. Okay, I'm gonna park my question for now. I'll have that later on over our chat. So it's already 1:20. So yeah, let's wrap this up. Okay, guys. Thanks a lot for joining in, and see you guys soon. Okay, bye bye.
Thanks a lot. See you. Bye.